And today we're going to look at Keras versus PyTorch. And we've started off with a couple of good questions in the chat, but I think that we would be making a mistake to start this examination without talking about this at a meta view, right? What exactly are we talking about when it comes to Keras and PyTorch? Like, what are they, right? And I'm asking that because there are clearly some newer people on the chat, and a lot of newer people watch my videos, and that's okay. So I want to start off kind of like that high level examination. So in the chat, we're going to start with participation right away. In the chat, just tell me, what's Keras? What's PyTorch? What are they used for, right? Because you guys know that I emphasize that a lot of these frameworks, a lot of these things you hear about, and these videos, it's all just tools, right? They're not magic. It's just tools. So what are they? Let me know in the chat. What are we talking about when we're talking about PyTorch, or we're talking about Keras? What are they? Leo says, buckle up, things are about to get hot. Leo, playing my hype man today. Thanks a lot, Leo. Appreciate that. Rahul says, hello, Dennis, how are you? Rahul, I'm doing well. Glad to see you back, my friend. Glad to see you back. Always happy to see my supporters come back. Thank you so much. So Rahul, right now the question in front of the chat is, what is PyTorch? What is Keras? What are we talking about? Right? Sometimes you hear people throw around these tools and they don't even know what the tools do, right? So let's make sure we start with a common understanding. I want to establish that baseline for all of us, that foundation. So tell me in the chat, what are they? What's Keras and PyTorch? I mean, they got to be correlated in some way, right? Okay, so Nilesh says Keras is a framework and TensorFlow and PyTorch get internally. Yeah, but that doesn't tell me what it is. Like, that's just three buzzwords, right? But we can't use a tool unless we know what it is, what it does, right? And that's what I'm really trying to emphasize here, guys. So many people chase these tools and, oh, I heard I gotta learn this, I heard I gotta learn that. But you don't know, like, what you're learning underneath, right? Like, what are they? Rahul says they are machine learning libraries. One is more focused on deep learning, maybe. Okay. All right. Any other replies? Like, what are we talking about when we're talking about Keras and PyTorch? Right? Like, you can't really, focus on this unless you know what you're doing, right? Like, what are they? Anis says they are both used in building and training deep learning models. Okay. Okay. Anis, do you want to be more specific than that? Yeah, because I think you're on the right track, but take it just one step further. Siva says TensorFlow is more focused on NLP. I don't know if I'm on board with that, Siva. I don't know if I'm on board with that. Anybody else? Why are we even talking about this? Like, why would you even use these? I mean, are we using buzzwords or are we using data science tools, right? What do you guys think? Sam says, I'm still getting a hang of PyTorch, which is designed to solve machine learning and deep learning problems, especially tensor manipulations. PyTorch is designed by Meta. But Keras and TensorFlow, I don't know much about them. Okay. Okay. Yeah. I'm on board with that definition, Sam. Yeah. Manoj says tools to build and train deep learning models. Yep. Okay. Manoj, give me your definition of deep learning models. All right, just take it one step further, just like Anis, right? Just give me one step further. Rahul, our good friend Rahul is back. I don't know PyTorch. I guess Keras is easy. Okay. Siva says TensorFlow lets us make graphs of data flowing through it. The graph is made up of nodes that stand for math operations. A link or edge between nodes is a multi-dimensional array of data. Yeah, but why? Like, what is that? Like, why would you need that? Why do you need nodes and edges? Lakshmi. Okay, guys. I think Lakshmi is giving us the best answer so far. Lakshmi says, doing good, excited for today's session. Thank you, Lakshmi. I'm excited too. Both our popular deep learning frameworks serve the same purpose of building neural networks. Yeah. That's a great answer, guys. That's pretty much what we're after, right? They're frameworks for building neural networks. That's basically the best answer right now in the chat. Because that's really what we're talking about today, right? What you're really learning is neural networks. And I really want to emphasize this, guys, because again, well, it's really two reasons. One, so many people out there are just chasing tools, right? Chasing tools. Oh, I heard this. Oh, I heard Google's using this more. Oh, I heard they're asking this on tests. Let me go. Don't do that to yourselves. That's not learning. You gotta learn the underlying fundamentals of what it is that you're going after. That's the first part. The second part is, do not make the mistake of saying, I learned neural networks, I learned Keras, I learned PyTorch, therefore I'm a data scientist. That's not always true. What it means is that you learned a tool. It's a tool that you can add to your overall data science toolbox, but it doesn't make you a data scientist. Because there's other tools you can use for data science, and there's other things that make you a data scientist that may not be code or framework related. Right? That's where the methodology comes in. The presentation skills come in, right? Your personality, how you explain things comes in. All of those make you a data scientist. But just because you take a PyTorch and Keras lesson from me doesn't make you a data scientist, right? But you gotta learn what it is that's the underlying functionality. Don't just chase the tools because so-and-so told you so, right? Because, I get so many questions like that in my messages and in my comments. Oh yeah, my best friend's third cousin read on LinkedIn that this other company said that I need to know this. Well, that's not being smart about building yourself as a data professional, right? So I'm glad we took the time to establish this foundation because, Lakshmi expresses it the best here. We're really learning about building neural networks, right? So Yassine says, from my basic knowledge, they are frameworks used for the development of deploying a machine deep learning models. They have pre-built algorithms to simplify. Yeah, they do, but they're not always helpful. They're less helpful than you think. At least in the real world, that's been my experience. Yassine also says the use of algorithms without the math from scratch. Yep, that's important. That's important to know that, right? The frameworks take a lot of the math out of it for you, which is something everybody should be doing. By the way, Dennis, thanks for teaching the ISLR book. That book was really useful. I'm so thankful. Oh, thank you so much, Rahul. Yeah, that was a fun series. Yeah, for those of you that don't know what Rahul is referring to, every Sunday I do a tutorial. Today we're focusing on a single topic, but that's because 3 weeks ago I finished the series teaching the Introduction to Statistical Learning book, which is a book everyone here should know. That was an 8-week series, and we had a lot of fun with it. We had a ton of fun. And I know that some of you in the chat also attended. But yeah, that's what Rahul's referring to. And Rahul, I appreciate the kind words. That was a fun series. I'm proud of everyone that came to that series, and that really went well. Manoj says to build a neural network. Yeah. Akshahar says, hello, sir. Hey, Akshahar, nice to see you. I think it's your first time, so welcome. Siva says, for deep learning, especially when you're training a model, you'll often have a ton of data that's all jumbled up and hard to work with. Tensors are a great way to store and use this data because they can hold multi-dimensional arrays and make it easier to feed the data into the neural network. Siva says, I don't know. It's what I learned so far. Okay, well, that's fair. That's fair. I know that it's what you're learning. I think the challenge here, Siva, is that you might be confusing the needs of a neural network from what a tensor does. Because the multidimensional data that you're referring to is a function of the needs of a neural network. So therefore, tensors are designed to handle them. It's not the other way around. Tensors don't handle multidimensional data because tensors want to. Tensors handle multidimensional data because that's what a neural network demands. Right? Like there's a difference. Like a chicken and egg issue, right? So keep that in mind as we go forward, okay? Leo, thanks for playing hosting duties there. Fatima, Keras is ideal if you want fast prototyping, simplicity, and integration with TensorFlow's ecosystem for deployment, okay? PyTorch is better for researchers and projects that need fine control over models, as well as for dynamic and flexible deep learning models. Okay. Casual Economist says, checking in. I'm here, just not able to chat as much today. Cool, Casual Economist. Glad to have you. I think you'll find this topic interesting. I know you want to advance your skills, so thanks for checking in. I really appreciate you. So I like Fatima's explanations. I'm so Fatima, and for everybody else, you all of you know that I like to emphasize flexibility of thought in your approach, right? So I'm not sure if I'm 100% comfortable saying, well, PyTorch is better for researchers, Keras is better for this. I'm not sure if I'm 100% comfortable for that. And I think that the developers themselves of PyTorch and Keras might disagree with you, right? They would probably view themselves as being flexible also. So I like your explanations. I think you're generally on the right track. I'm just not sure how comfortable I am making those distinctions, Fatima. Because, it's important to stay flexible, right? And as I said, today is a display of my flexibility also. You guys know that I poo-poo PyTorch. I make fun of PyTorch. But, I wouldn't be much of a data scientist if I didn't look at it more, right? That wouldn't be me being flexible in thought, right? That wouldn't be me open to changing my opinions, which I encourage everybody to do in science, right? So, you're on the right track, Fatima. But it's important for all of us to stay flexible on what every tool can be used for, right? But I overall I do like your answer, Fatima. All right, so we've established that we're looking at neural networks. Okay, so now I want to talk about. I'm trying to think of what part I want to go to next. So the next part I want to go to is I want to share a little bit about how I learn neural networks. And I found it to be very effective, completely moved me forward in terms of deep learning. So a lot of you have mentioned nodes, a lot of you have mentioned edges. We've talked a little bit about multidimensional math. And the best way I found to put all of that together is it was a two-step process via the same book. There is a book out there called Build Your Own Neural Network by Tariq Rashid. I believe he teaches at a university in Iran. Excellent book. And he talks about building neural networks, and he builds it with Python code, and he shows some of the math, and he does it without a framework. So my encouragement to you, the way that I learned best was to go through that entire book and understand how a neural network comes together in pure, in raw Python code. I think that's a very valuable exercise, to build an entire network just with Python code. And then when you're done with that, it's going to take you a little while, but when you're done with that, start all over. And then based on today's examination, you can pick PyTorch or Keras, and then do the entire book with your framework, with either PyTorch or Keras. That was a super, super valuable exercise for me to do. And at the end of those two steps, you should have a pretty good understanding of neural network. But really, what I'm trying to impress upon you, and kind of related to today, is that your goal when you're learning neural networks is to learn a framework, learn it well, and then standardize your team on that framework. Because that's how neural networks are actually carried out in the real world. It's not a math exercise. It's kind of sort of not a coding exercise either. Because remember, we have an employee, ChatGPT, who's going to do the coding for us anyways, right? But the importance is to know a framework and know how to use it backwards and forwards, and have your team standardized on it. Because then everybody is working within the same framework. If you're talking about other things like regression or your visualization, it's okay if you have your team members working on different frameworks, right? It's not the worst thing in the world, right? A chart is a chart, right? But when it comes to neural networks, you're going to be writing some, relatively complex code. You're going to want to have people working on the same framework. You're going to want that code to be interchangeable among people. Hey, I wrote this section. Can you write that section? Okay, yeah, sure. You're going to want to have that ability to work back and forth with each other. Neural networks aren't something you can just change on the fly and say, oh yeah, we started that in Keras, but we got this new guy who only knows PyTorch, so we're going to switch to PyTorch. They're not going to say that, right? The code is too involved to be able to do that, right? So that's really kind of what you want to do. Now, coming in from the other end, if you're coming in from the outside, you're new to the team, you're going to want to also adjust to what that team has. Maybe you are a Keras background and you're going to have to learn PyTorch, right? They're going to ask you to learn PyTorch, or or vice versa, right? So again, that's why it's important for us to kind of start with an understanding of what it is that we're talking about. Because that way you're understanding it at the conceptual level, and then we'll go deeper into the framework level. Okay? So let me kind of look at my chats here real quick. Fatima says, I think that because Keras is designed to be user-friendly and efficient for quick development, while PyTorch offers more control and flexibility, which is ideal for complex research-focused pro. Yeah, but what's user-friendly? What's more control? Those are all relative terms, right? It all depends on how you look at it as an individual, right? Like, what's more control to me is not enough control to somebody else, right? It's all relative. It's all relative. Michael says, happy Sunday, Sir Dennis and everyone. Michael, welcome back. Glad to see you. Thank you so much for the greetings. Happy Sunday to you too. Hope you're doing well. Rahul says, can I ask a very naive question? Hey, there's no such thing as a bad question here, guys. This is why we meet on Sundays. It's supposed to be a longer tutorial, right? What are frameworks? Okay. All right, chat. There's a question in front of the chat. What's a framework? What do you guys think? Who wants to help Rahul? Rahul wants to know what's a framework. Somebody give me their very quick elevator pitch on what a framework is, please. Rahul also asks, how many frameworks are there? Good question, Rahul. So virtually every concept in data science has some sort of framework to help you. Like Rahul, I know you were there for some of the Sunday classes in the ISL book. So we use scikit-learn as one of our frameworks to help us with like the regression stuff, right? I think we also use scikit-learn for some of the clustering stuff we did, right? So really there's a ton of frameworks. And also they're not exclusive to data science. They're kind of, for anything you want to do with coding or software engineering, data science, really anything having to do with code, there's probably a framework for it. Or sometimes you'll hear it expressed as an engine, right? Engines, frameworks are kind of correlated terms, right? But there's a ton. For neural networks, PyTorch and Keras are definitely the most popular. I'm assuming there's others. But PyTorch and Keras are very popular for neural networks. Okay. Rahul says, actually we have two Rahuls, excuse me. So Rahul Kumar says, there's a lot of frameworks. In simple terms, frameworks are a set of tools. Yeah. Rahul, and he goes on to add, and the frameworks are generally user dependent. Yeah. Absolutely. Cigar says they are pre-built structures. Yep. That's a good way to say it. Lakshmi says frameworks are pre-built software libraries or platforms that provide a set of tools for developing applications. Yeah. That's a pretty good explanation too, right? It's pre-built libraries, pre-built formulas, pre-built design or architecture. It could be a lot of things. But basically, it's tools that help you speed all of that up, Rahul. It helps speed up your development because a lot of the code is built in. Right? So one of the keys is just knowing what is the problem you're trying to solve, And then what is the framework that can help you with that, right? Then, and again, that's kind of why I started this conversation like that. Because the problem that we're really trying to solve is neural networks, right? Some of the responses from earlier kind of went off the rails a little bit, right? But the core problem is neural networks. And then when you know that, you say, okay, well, what frameworks are out there? And you can say, oh yeah, okay. Here's a couple options. Right? But guess what? That's also where AI comes in. And again, if you go back to the Sunday classes, if you think back to that, we did that, right? I think it was for SVMs. When we talked about SVMs, my first prompt at ChatGPT was, I want to work in Python. I want to work with SVMs. What are the frameworks available? Like, that's a legitimate first question for you to start off with. And say, hey, I just need general guidance on what's available. And ChatGPT is pretty good about giving answers. And we'll start with that today. I mean, I already know what I want us to use, but we'll start with that today. We'll see what ChatGPT says. Like I said, PyTorch and Keras are the most popular. Maybe there's others. Let's find out. We have our new employee, ChatGPT, that can help us with that, right? Yassine says, I don't know if my answer is right, but here's my shot. Yassine, that's okay. There's no such thing as a bad answer, right? Think of libraries as toolboxes and frameworks as a store who have a lot of toolboxes and methodologies on how to work with all of them together. Yeah. I like it, Yassine. Hey, guys, don't be embarrassed to give your answer, right? I mean, nobody picks on you, right? We try to keep the conversation positive, so I don't want anybody to be shy about replying, right? I may tell you that maybe it's not the right track, but that's okay, right? Rahul says, thanks, Dennis, and thank you all for your responses. Very helpful. Okay, cool. Yeah, hope that answers it for you, Rahul. Manoj says, frameworks are methodologies. Sometimes it can help you. The methodology, sure. Sometimes. All right. So look, I want to make sure we get to the code sooner rather than later. But I think there's one more thing we need to learn. Okay? So I'm not going to ask this in the chat because I think it would take too much time. But what exactly is a neural network? Right? When you hear that, it's a very complex answer, a very complex sounding term, right? Like, or you read about it in the news, or, oh, neural networks, that sounds really complex, right? But I want you to think of this because, again, this is the way that Rashid Tariq explains it in his book. I don't want to take credit for this because this is his book. Neural networks, in a nutshell, it represents the human brain. That's it. That's why it's called a neural network. It's a representation of the human brain. Okay, how does the human brain work? Well, the human brain takes in an input. It evaluates that input. It decides whether to send an electrical impulse or not. And that electrical impulse goes to another neuron, right? And by the way, I forgot to say, the inputs are all neurons, right? It sends an electrical input to another neuron. That neuron evaluates, and then it decides to whether or not to send an electrical input. And then it's called a network because there's a ton of neurons. And they're all doing their own processing. And they're all firing to other neurons. And then those neurons do their own processing. And then they're firing to other neurons. So it's this big network of these neurons in your brain and throughout your body that decide whether to fire or not. That's it. All right, that's how your human body works, and that's what a neural network tries to represent. That's it. That's what a neural network is. It's a representation of the human brain and the human body. So when my brain sends an impulse to say, raise your right hand, it's sending that from my brain. You know, it's my brain is firing to the right neurons in my muscles, in my nerves that are telling me whether yes or no to go up or down with my right arm, right? Right now, as I'm speaking, all those little neurons are deciding to fire or not and send my arm up or down. That's it. That's how the human body works, right? The human body is an electrical machine, firing at all times. So that's all it's doing, right? My brain is saying fire yes or no to millions and millions of neurons throughout my body and my arm and all that, right? And that's it. That's all we're doing. We are going to represent that in code. And when you do that, guess what? You have a neural network. That's what a neural network does. All right? So from what I said, we're going to have our inputs. We're going to have the little neurons in between. And then we're going to have the result. Right? Because the result is my hand either went up or down. But that's it. That's all we're doing in code, guys. So if anybody's confused or intimidated by neural networks, that's all it is. It's a representation of how the human brain and your body works. What neurons are you using? How many are you using? And do they fire or not? That's it. That's how your body runs, and that's what we're going to be representing in code. So in the neural network sense, in the data science sense, that means that a neural network has a minimum of 3 components that we're going to work with. 1 is the input layer. 2 is what's known as the middle layer. And 3 is what's known as the output layer. So that's the minimum. And that middle part, you can have as many of the middle layers, or sometimes known as the hidden layers, or processing layers, sometimes you might hear it. Those middle layers can be as big or as small as you want. And they can be as many as you want. You can have as many hidden layers as you want. So your input is based on the nature of your problem, how many inputs are available. Your hidden layers, your processing layers, that's a function of kind of like building and designing your neural network. And then the output is a function of what are you trying to solve? Do you need a binary output? Do you need a categorical output? Things along those lines, right? So that's really kind of what we're after when we're talking about neural networks. What does our input look like? What do our hidden layers look like? And what do our outputs look like? And then remember how I mentioned that there's some processing that goes on? That's also a function of your layers to some degree. And then remember how I mentioned the node either fires or not? That's going to be a result of what's known as an activation function. The node either activates or it doesn't, right? It fires or it doesn't. It sends that impulse or it doesn't. So I know that I'm speaking a little bit in the abstract. It's going to be a little bit better when we see it in code. But I want you to keep those three things in mind, because those 3 things are agnostic to whatever framework you're going to use. Every neural network, no matter how you write it, no matter what language you write it in, you're thinking in those terms. What are my inputs? What are my hidden layers? And what are my outputs? All right? That's it. That's neural networks in a nutshell. You guys with me on that? Give me some feedback in the chat, or if you guys have other questions on neural networks, let me know, because I know that some of you are new to neural networks, and that's okay. But let me know. Are you guys with me? Meanwhile, I'm going to start setting up some stuff we're going to need. Oh my, I didn't even start up my VS Code. Let me start that. Lazy Dennis. Oh shoot. I guess we can go here. All right, so I got that, and I got my terminal windows. All right, guys, so I'm ready to get into the code side. I hope you guys are ready too. I'm excited about this. Yeah, I think I'm ready. All right, guys, so you guys with me on this? Maybe it'll become easier once we start looking at code. So let me start up my classroom view. Okay, guys. So what we have here is VS Code. So if this is your first time joining my Sunday class, another thing I emphasize is that we are professional developers. Professional development is not done in notebooks. I know I'm breaking a lot of preconceived notions there. But if you want to be a professional data scientist, professional data science is not done in notebooks. It's done in code and in terminals and in programs, sometimes scripts. But very important for you to start working in notebooks, in raw code as early as possible. It adds some professionalism to your work, and it also makes your work easier to deploy because your work will be deployed in very complex server architectures, right? You can't deploy a notebook, right? So everything that we do is going to be in raw code. Second is that we have an employee. Our employee is called ChatGPT. We are not going to be writing any code ourselves. We're going to be relying on ChatGPT to help us with the code. It's a complete mistake for us to sit here and start writing raw code. No need for it, right? And third, what I'm trying to do is we're going to start doing some baselines between Keras and PyTorch. And we're going to start doing, we're going to do that by writing as closely as we can the same neural network in both frameworks and seeing, what the code looks like, and seeing if there's any difference in the results, right? That's basically, it's kind of a little bit of our own benchmarking approach to understanding the frameworks. But the real benefit here is you'll be able to see the code. We're going to walk through some of the code, understand what the code is doing, and then be able to say, okay, yeah, I get that. Or, hey, I'm just gravitating more towards Keras, or I'm gravitating more towards PyTorch. That's okay, right? That'll be a big benefit for today. Okay. All right, so let's get started, guys. So first of all, what we need a common data set to work from, right? We need a common data set that's used by both frameworks, that have the same answers, right? And then that way we can say, okay, yeah, it was the same data set. We asked it to do, the similar neural networks, and this is the result it gave us, right? That's a way that we're going to keep it fair. So let's start by that. Let's start by doing that. So we're going to come here. We're going to go to ChatGPT and ask it for a synthetic data set that we're going to use, that we're going to utilize. Okay. So again, we're going to try to be very specific in our prompts and see what happens. And we wanted to make it a supervised data set, right? And actually, and let's ask for 10,000 data points. And let's ask for 5 classes. Right, we kind of want this data set to be challenging, right? Because the more challenging it is, the more the differences between the frameworks will become evident to us, right? 5 labeled classes. Yeah, I think that's enough. And then I want to make sure we save the data set. Leo says the white theme. Leo, you already know that I'm struggling by saying that I'm going to be working in PyTorch. Don't start with me, Leo. Don't start with this. Is hard enough, please. Okay, so it looks like it's gonna give us it's gonna use the same method that we had last time, right? 10,000 samples, 20 features, 5 classes down here, and it holds a random state so that we can use it next time. So this looks fairly reasonable. Let me copy the code, and I'll bring it over to VS Code. I'm gonna put this in Keras for now. We'll just call it make data. All right, can you guys see that, or do you need me to make it bigger? Maybe a little bigger? Yeah. Is that better, guys? Can you see that? What do you guys think? I think it's a relatively, this is reasonable code. Give me some feedback. What do you guys think? I mean, I'm seeing a good number of samples, good number of features. It's using 20 features. Hey, Nameless Coder, welcome. Glad to see you over there on Twitch. But I think it's using, relatively reasonable features. Or reasonable code. What do you guys think? Yassine says, looking good. Yeah, Yassine, I think so too. It looks very similar to what we used just last week, right? Leo says, looking decent, yeah. Looks good to me, says Anis. Yeah, looks good to me too. So let's use this, guys. So before we do this, I want to quickly show you my terminal. Is this Keras? This is PyTorch. Let me bring up my Keras window. So what I did last night in preparation for this is very simple. It's just a standard Conda install of my the basic environment for us to use. So I want to create separate environments, right? That way the code is completely apart from each other, right? There can't be any interference. And this one is called Keras test. The other one is called PyTorch test. And I have some very, I basically just let Conda do its own install with Python 3.1.1. And you can see here it's installing pip, it's installing wheel, installing Python. So very basic items. So I think that this is, I wanted to show you this just to kind of show there's nothing up my sleeve here, right? It's all just a pretty standard environment that we're going to use. So here, let's go ahead and verify that our file is there. It is. So I think we're ready to just run Python make data.py. Actually, you know what? I might need some library installs. Yeah, no module name name numpy. Okay, so pip. Actually, I'm gonna need pandas too, because we're doing data frames, and I believe that pandas installs numpy. So we should be okay by installing pandas. Yeah, you can see that the numpy install is happening here underneath the hood as a dependency. Okay, so let's try this again. Okay, no module name sklearn, that's all right. Oh, come on, Dennis. So we should get to a data set at this point. Okay, so there we go. Synthetic data set has been created. So if we go back to our code, here it is. So yeah, so it named the features across the top, and that's okay. We see our different labels. So our labels is our last column, 00432413. Yeah. So this looks like a fairly reasonable data set, right? So yeah, I think this is something that we can proceed with. So same thing that we did last time is I want to make sure that I'm copying the data set so that it lives in both directories, right? It wouldn't be fair for us to ask it to go across directories for one framework and not the, or one test and not the other. So I want to make sure that we copy this and put this in the PyTorch, okay? So now both the Keras and the PyTorch directories have the same synthetic data set to work from, okay? All right, so I think that we now have our basis to work from, right? I think we're ready to go start our first framework, our first neural network. So while we're already in Keras, right? So in the Keras terminal, so let's go ahead and start with Keras. Actually, that's right. So somebody had asked a question about the frameworks for neural networks. So I know Keras and PyTorch. There might be others, right? Let's see if our new employee knows. So all right, so ChatGPT is telling us it knows TensorFlow, it knows Keras, it knows PyTorch. Ah, Theano, that's right. Theano's another option. Okay, MXNet looks like it's the AWS tool. Microsoft Cognitive Toolkit. Okay. Excuse me. JAX. Fast AI built on top of PyTorch. Okay, interesting, but why not just go to PyTorch directly? And that's it. Okay, interesting. So Lakshmi, Lakshmi, I hope you see what's on the screen. So this kind of speaks to Lakshmi's previous statement. Beginners, Keras via TensorFlow. Flexibility and control, PyTorch or TensorFlow. Okay. Research, PyTorch is commonly used in research environments. All right. So Lakshmi, that kind of speaks to your earlier statements, right? So yeah. You know, it sounds like Lakshmi was on the right track in terms of saying that, you know, maybe some people who need that finer tuning would gravitate more towards PyTorch, whereas Keras might be easier to start up with. So it sounds like ChatGPT would support that, right? That's very interesting. Very interesting. Okay. You know, and you know what? Maybe this will become more evident as we get down into the code more, right? All right, guys. So let's do this. Now, last week when we did this, ChatGPT wanted to add the data creation code all over again. So we had to be explicit and tell it to use the saved version of the data. So I want to make sure we're explicit again in that too. Okay, cool. I like this. Oh, right. We also... One more thing we need to add, guys. So remember, this is neural networks, and we asked for a supervised solution, right? Which means that understanding our confusion matrix is also important, because that gives us a lot more metrics to work from. And I didn't add that here. Here, it's only going to show us our accuracy and our loss, which is great, but not nearly as informative as a confusion matrix. And I didn't explicitly ask that, right? So I want to make sure we modify our prompt to give us as many metrics as possible. But overall, I like the code. A couple things caught my eye that I really like. So I want to keep the same code. Okay, so it's going to add a confusion matrix at the bottom, which is kind of what we want. Yep, generate the confusion matrix, labels for the 5 classes. Yep, okay, this looks great. So let me copy this. And now in Keras, we're going to have our neural network. All right, I think that's big enough to see on the screen. What do you guys think? And let's change our environment. Keras test. And yeah, we're going to have to do an install of TensorFlow, it looks like. But that's okay. The Fit House says, I'm having trouble viewing the full screen. The pinned YouTube links at the video is not available. Thanks for that feedback. I don't know why it would tell you that. I'm pretty sure that's the link for the video. I know other people have used it. Let me put the link again in the Instagram chat. All right, I put the link again in the chat, okay? All right. So what do you guys think? To me, this code looks pretty good. I think we're on the right track here, right? So this first part here, fairly standard. Fairly standard. Yeah, thanks for that feedback, Rex. I don't know why that link wouldn't work. I mean, other people have used the link, but thanks for that, Rex. Yeah, so this looks pretty standard as far as the pre-processing, right? It's going to go ahead and separate out the features from the label because the label's our target, right? We know that we want to get to the label. It's going to go ahead and tell Keras that it's a categorical problem that we're trying to solve. It's going to go ahead and give us a train test split where our test size is going to be 20% of our entire data set, which means it's 2,000 records, right? Which an 80-20 split is very reasonable, very common. It's going to scale our data, which is also very common in neural networks. And here really is the key. This right here is the key. This is where like the Keras library really goes to work, right? This is like right here, whether you realize it or not, this is where a neural network is being formed. All right. So remember, quick review, right? I said there were 3 components. There was going to be an input layer, a hidden layer, and an output layer. And I also told you that your input layer is a function of your data, right? The problem you're trying to solve. The middle layer can be whatever you want it to be and however many you want it to be. And the output layer is also a function of the problem you're trying to solve. A yes, no, multi-class, whatever, right? You can see that here, right? Model add. And by the way, I love how it labeled it, right? So this is our input layer, right? So it's going to add to our model this layer, right? There's going to be 64 neurons with the input dimension of 20. In the chat, tell me why there's 20 on the input. Why did it choose that? We didn't choose that, right? Why does the input layer start with a dimension of 20? Yassine says the data has 20 features. Is he right? You can just say, hey, I agree with Yassine. Right? Nobody's going to pick on you. Or you can come up with your own answer. Maybe Yassine's wrong. What do you guys think? You know what? I'm going to hide this because I think okay, cool. That shows more of the code. Yeah. Michael says because it has 20 features, I guess. Yeah. Yeah, they're right, guys. Michael and Yassine are correct. Yeah, Rahul, you know what? As soon as I asked the question, I saw that and I was like, oh my God, but I didn't want to say anything. But you're right. It's in the comment above, guys. Right? It's in the comment above. But yeah, but both Yassine and Michael are correct. And that's exactly what I said, right? It's predetermined. ChatGPT came up with a data set with 20 features, therefore your input has to have 20 features. Right? So yeah, they're correct. 20 features to 64 neurons. Next is our hidden layers. And now it's telling us that the second hidden layer has 32 neurons. And the third hidden layer has 16 neurons. Anybody have any comments on that? Why would it do that? Why are those numbers significant? Why are there 2 layers? Anybody want to comment on that? Anything jumping out at anybody? Why are there 2 layers? Why are they sized like this? It's divided by k dimensions 20. Okay. Anybody else? Lakshmi says how it decided to take the number of dents. Yeah, that's the question, Lakshmi. Do you have an answer for that? Hey, welcome back. I'm sorry, I can't read your name in Arabic, but I know you've been here before. Was it Abdelez, I think was your name? Remind me what your name was. I can't read it in Arabic. Ah, Yassine. Yassine is saying it's not actually meant to be like that. It could be any number of layers neurons, but I guess this degradation of the number of features helps in selecting the most significant variables. Okay, from one layer to another. Yassine, my man. Yep, Yassine is right. Remember my previous conversation, guys. Right? I mean, this is kind of a trick question because the answer is it can be whatever you want it to be. Right? I said that. That middle layer, the hidden layers, can be anything you want. It can be anything you want. If you guys attended the ISL course, remember how we talked about hypertuning and parameters, right? And how you kind of want that because that's where the experimentation comes in, right? Remember, guys? You want that, right? You want to have, as I tell my teams, I call them levers to pull. You want those options. If you had no options, you'd have no experiments, right? So hidden layers is one of those ways that you can tune your algorithm. They can literally be whatever you want. So Yassine is right. It's whatever you want it to be. However many layers, however many neurons. Like that's part of the skill. That's part of your design for neural networks. Right? So there is no right answer. You decide that as a data scientist in your experimentation, in your approach to your problem. Right? Manishegi says you should use leaky rarely to. No. How can you say that? You can't say that. We haven't done any experimentation. You can't say that. I disagree. Totally disagree, because what you're expressing there is researcher bias. You have no basis to say that we should be changing our activation function. Sorry, my friend, but that's just plain wrong. You can't say that. You have no basis for saying that. That's not a good practice. Rahul says, so would more layers equal better accuracy? Rahul, great question, my friend. I love where you're going with this. You don't know. That's part of the experimentation. You don't know. But in theory, yes. Right? In theory, right? The theory of neural networks, more processing, more better. In most cases, right? Let me put an asterisk on that. Because there is a little bit of an asterisk on that. But yes, in theory, the more layers you have, the broader the neural network, the more accurate it becomes. Depends on your problem, depends on your inputs, the quality of your data. But yes, in theory, more layers does do better. But again, that's a function of your experimentation, right? It's one of these like quasi hyperparameters that you can play with. But here's the thing, Rahul. It comes at a trade-off. Okay? It comes at a trade-off. Here's the trade-off. It applies to all of these layers, but just to kind of keep it simple, let's focus on these two hidden layers. Right? We're going to focus on these two hidden layers right here. Right? If you have, remember how I said earlier that the human body is just these connections of neurons, and then they decide to fire and they go to other neurons, and then those neurons go to other neurons, right? It's like this big network. If you have 32 neurons here, and each one of them has to go to 16 neurons, how many calculations is that? Right? Because one layer, you're going to have 32 neurons. And each one of those 32 neurons is talking to 16 neurons on its own. Right? How many is that? How many calculations is that? Okay, it's Abdelaziz. Thank you so much. Welcome back. I'm really upset you put me on charge. Not really sure what you mean by that. Please explain. Money M says, hi Dennis, first live event with you. Glad to be. Hey, glad to have you too. Welcome. Glad you're here. So Money M, the question in front of the group right now is, if you have 32 calculations happening in one layer, and each one of those is going to 16 other calculations, right? How many calculations is that? Rahul says 512 calculations. Is he right? Anybody else want to give an answer? Yassine says 32 times 16, which I believe is essentially Rahul's answer, right? Yeah, so okay, yeah, so most of you guys are getting it, right? Keyshawn also 32 times 16, yeah. Right? And remember, these are your hidden layers. You've already gone 20 not calculations, but 20 objects, 20 numbers to 64. You've gone 64 to 32. And then you've gone 32 to 16. And then you got to go 16 to 5. That's a lot of processing, right? And Rahul, I skipped over your comment, but yeah, you're right. It's trade-off on processing time and power, right? So yes, more layers, more better, but performance is your trade-off. Time is your trade-off. There's other trade-offs too, which is probably outside the scope of today's discussion. But you guys should be aware of this, right? Yeah, Moniem, yeah, you guys are getting it, right? It's a lot of processing power, right? And this is why neural networks take so long to train. Because you do have the big neural networks that are put out by Google, by Meta, right? There's examples out there, right? They've open sourced some of their neural networks, and they have an incredible amount of layers with massive numbers of nodes, right? So that's how you start seeing, why neural networks take so long. Because there are neural networks out there with a lot of hidden layers, but each layer represents processing power, right? So yeah, I mean, I love how you presented that, Rahul, because it is, in theory, better to have more layers, right? But there's trade-offs. Here's another thing that's funny, guys. And you'll come across this sometimes with like these old school software engineering guys, old guys like me. So, and some of you might know this already, right? Because I know some of you have a software development background. But in software development, there's always that saying, right? That don't be a lazy programmer. You can't solve bad code with hardware, right? You can't throw hardware at a problem, right? You always hear like the old school software engineering guys say that, right? But that's not true. Neural networks is one of those rare problems in computing, right? Not just data science, but in computing, that you literally can dedicate more hardware to and see an improvement. Because there's just so many calculations happening. So it's one of those few problems where, yeah, you can solve with hardware. And that's exactly why you hear about, Google's building a new supercomputing center. NVIDIA this, NVIDIA that, because the networks are getting more complex. The networks literally do need more hardware. Like there's a ceiling where the hardware is a limitation. It's not coding, it's not skill, it's physical hardware that's capping you out. Capping out these big companies on what they can do. Right? But this is kind of where it begins. It begins in those hidden layers where, again, it's one of those rare problems in all of computing where you literally can throw more hardware at it. It's not lazy coding like the old guys, right? Because the old guys say, that's just lazy coding if you're solving it with hardware. No. Neural networks are complex. There's a lot of calculations going on. So keep that in mind, guys. I always think that's fun because when I first learned coding, I was like in high school, and I had a teacher who was a real knucklehead. He was just a jackass. I didn't like the guy. But and he was one of those guys, right? You can't write lazy code. You can't solve it with hardware. No, you can. And neural networks do require a lot of hardware. Okay, Rahul, you're just asking the great questions, man. You're on a roll. Rahul is asking a great question. What is the activation part of these layers? Great question. So again, remember how I said that all these neurons are firing and they're deciding whether to raise my arm up or down, right? And I said that the neurons are processing and deciding whether to fire yes or no. That's the activation function. That's the activation function. Saying, should I did the calculation, here's the answer, should I fire yes or no? That's what the activation is that you're seeing here. You're deciding which activation function, or said another way, what criteria to use on whether to fire or not. That's what the activation function is. So you're telling each node, hey, I want you to do this calculation and then use this criteria, use this activation function to decide if you're going to fire or not. So that's what the activation function does. And there's different types of activation functions. Some are more problem specific than others, but it can be used as one of those parameters that you experiment with and say, well, this problem is really more suited to this activation function than the other one. You can do that. And as you can also see, there's a variation in the activation functions, because you can also mix activation functions. But yeah, good question there, Rahul. Fatima says, while adding more hidden layers can enable a neural network to learn complex patterns, does this also pose a risk of overfitting? Maybe, maybe not. Depends on your data, depends on your overall network, depends on your trained test split. It's a risk, Fatima, but not always. It just depends. There's no single answer to it. So it's a concern, you know, and you're right to be aware of it, but there's no guaranteed yes or no on that. I mean, you know, if anything, like something like this is a very small, tiny neural network compared to some of the other neural networks that are out there. And if they haven't seen overfitting, then I think it's probably fair to say that overfitting is less likely to happen than most people would think it is. Yeah. So you should be aware of it, Fatima, but I don't think it's as big of a risk as most people make it out to be. All right. So something that I think is slightly unique to Keras is that Keras does go through a little bit of a model compilation process to make sure that you are, kind of in compliance with their model design. And then here in the model fit, this is where the magic happens, guys. The model fit is where you're actually training your model, right? Because here's where you're saying, this is my train, this is my test that I want you to use for my validation numbers, right? Because validation numbers are very important. These are the number of epochs I want you to run. And then go ahead and put out my accuracy, my loss. And then we ask it to also do the predictions so that we can have a confusion matrix, right? So the rest of the code is fairly standard, right? You're going to use this for most neural networks out there. But again, right here, this is where this is like the Keras specific code. All this right here. All right. So I think that we're ready to run this. Let's see how we do. Yeah. So let's go for it. Oops, is that what I wanted? Yep, that's Keras. Okay. So LSL. Yep, there's our neural network. So let's go. Cannot open file. Oh, it's an underscore, not a dash. Oh, no, that's right. I didn't do TensorFlow yet, did I? I think it's just TensorFlow. I don't think there's a... There we go. Thank you for your explanation, Dennis. Yeah, you're welcome. Dilip, your explanation is very easy to understand. Thank you so much. I appreciate that. You know, I take a lot of pride in that. You know, I think I do all right explaining things. You know, I take a lot of pride in that skill. So thank you so much. All right, I think we're ready to go again here. All right, it's gonna work this time. So it's probably taking. Oh, Matplotlib. Sorry. I think that's the name, right? Or yeah. All right, one more time, guys. I think it takes a while initially because it's loading all those data points, but we should see some more Keras specific results here. There we go. There's our epochs. Okay. All right, guys. So there's our epoch. There is our test accuracy of 0.089. And then here's our confusion matrix for each one of our 5 classes. So test accuracy is coming out at 0.89. What do you guys think? You can also see the progression here, right? This progression is telling us that the first epoch was 0.71, 81, 83, all the way up to 89. So what do you guys think? What do you guys think? Rahul says, if your explanations weren't as good, you wouldn't have reached 27K subscribers in such a short time. It's a dream for many YouTubers. Thank you. I appreciate that. Yeah. Yeah. You know, like I said, it's one of my skills. It's, you know, I've been told that before by, you know, managing directors and other people. So I'm using that skill, right? Like, why work for somebody else when I can use my skill for myself, right? But yeah, I appreciate that, you know, and I'm glad. I'm really glad to get that feedback from you guys, and I'm just gonna keep going. I'm gonna keep going, giving you guys the best explanation I can. So thank you so much for saying that. Yes, what do you guys think? Lakshmi says seems good. Okay. Rahul says accuracy of 8.9 is good, but also depends on the context of the problem industry. Absolutely, Rahul. I love that. Yassine says, I think it's good depending on the problem. We can fine tune to improve. Yep. Maniam says, I think we can improve it. Yep. Anybody else? Manoj agrees with Rahul. Yep. Depends on the context. Absolutely. Context super important. Your business use case super important. Please, Dennis, can you explain the results? I will, Michael. I will. Let me start getting some feedback here. For a for a synthetic data set, it's poor performance. Maybe. Leo suggests maybe adding some depth. You mean depth to the neural network, Leo? Like more layers? Or please help me understand what you mean by depth. What is the difference between accuracy 92 and validation accuracy 89? Okay. Great question, Rahul. We'll get to that. I think accuracy depends on the problem at hand. I believe we can try to improve it. Random question. The validation accuracy is supposed to increase in each subsequent epoch and validation loss is supposed to decrease. Maybe. Yep. Anybody else? Last call. Last call for answers. I see the accuracy of class 2 is better than others. Okay, great. Yeah, good observation. Good observation. For those of you guys, just to right here, this is what Yassine is talking about, right? Class 2 is actually classified fairly well, right? Those are actually really good numbers, but it's just good for that one class. As you can see here, the next class at 314 is probably not, certainly not as strong as this one. Not terrible, but there are clearly some mistakes being made there. So yeah, Yassine, good catch on that. Right? There's clearly, this class is clearly outperforming the others. Do we have a way to modify the threshold? I'm sorry, which threshold are you referring to, Yassine? Not sure what you mean by that. Maniam, Maniam, this is your first time attending. You're giving a great answer. Possibly we could start by increasing the number of epochs and monitor validation accuracy loss in addition to model training accuracy. Maniam, that's a great answer. Great answer. And honestly, that's what caught my eye too, right? And Leo, that's why I asked you what you meant by depth. Because remember, guys, you could modify the neural network, but what about the training? What about the training itself? That has depth too. We choose the depth, right? Look at the trend of the validation accuracy with these epochs. It's on an upward trend. It's a good trend. We just didn't do a lot of epochs, right? So if one of my staff showed me this, I'd say do another 10 epochs, go to 20, right? So that's a great observation of Maniam, right? Why mess with your neural network when you're on an upward trend? You're not always going to be on an upward trend, but just change the epochs. Just train more, right? So I know there's people that are new in the chat, so you're going to be saying what's an epoch. Okay, so I could give you a technical explanation and all that stuff, but let me break it down for you real simple. Remember when you were in school and you had like semesters for each class, right? I think it works this way internationally, but most of the time you have a school year and then you have like 2 semesters, right? Take classes some semester, then the next semester, right? So an epoch is like a semester in college. And you're going to take a class during that semester. Okay? And you're going to go and you're going to finish that semester. What if you could relive that semester and you're going to take the same class with the same notes and the same exams? Wouldn't you do better the second semester? What if you could take it a third semester? Same notes, same test, same class. Wouldn't you be doing better the third semester? Because now you learned the first semester, you improved some mistakes in the second semester, and now you get a third chance to improve those mistakes. Right? What if you had a fourth semester? Same class, same notes, same exams. How good are you going to do your fourth semester? Your fifth semester? Your sixth semester? That's an epoch. An epoch is training your neural network, except that it retains all the information it learned in the previous epochs. So that's an epoch. An epoch is like a semester in school. And you get to relive it over and over and over and improve over and over and over again. Okay? That's an epoch. That's how I want you to think about it. So that's why, again, going back to Maniam's observation, yeah, our epochs are going like this. Why would you stop? Again, there will be a diminishing return, but we're not there yet, right? We still have a little bit of a ways to go. And also, to emphasize, keep in mind that even though we are focusing on Keras and PyTorch, epochs is something that's fundamental to all neural networks. It's not exclusive to Keras. It's one of the powers of neural networks that you can sit there and retrain it over and over again, right? But when you hear epoch, I want you to think about that analogy, because that's really what it is. You're letting your neural network learn all over again while retaining the same information it learned in previous epoch. So it just gets more and more powerful as it goes, the more epochs you give it. All right. Yassine says, I always had that question for neural networks. Yeah, but I don't know what you're referring to, Yassine. The threshold? Not sure. I get what you mean. Hey, Sam, welcome back. Glad to see you. I hope you're doing well in Mexico. Leo says, trigger warning example. School wasn't that bad. Come on. All right, guys. So, yeah. So I think that we can do more with epochs here, right? I think we could easily say, hey, let's see what happens after 20 epochs, right? But who wants to look at PyTorch? Right? If we're going to do a benchmark test, we need to get our PyTorch side going, right? We can come back and play with the Keras stuff, because I see a lot of interest in the Keras stuff, and basically fine tuning neural networks in general, right? I get it. It's interesting, right? But let's be fair, right? Let's go to PyTorch. And maybe some of you will like the PyTorch better, right? But I'm glad that all of you have got to have, a feel for what the Keras code looks like. Because see, to me, this code just makes sense, right? Like I can easily see where I can add more layers. I can easily understand why this is the dimensions, right? So that's why for me, I tend to gravitate towards Keras because of that. But let's look at PyTorch, right? So let me go over here. Let me start a file for PyTorch. So this is going to be our neural network. .py. And now we're going to tell our employee that we like that, but now we want to see it with PyTorch, right? That's kind of what we did last week, right? Just say, hey, I like the code, keep the same structure, but show it to me in PyTorch, right? All right, so let's keep doing that. So same neural network, same data, but this time we want to use PyTorch. The same data, but this time show it to me using the PyTorch for the neural network. I knew I made a mistake in there somewhere. All right. All right, here's the same neural network using PyTorch, working the synthetic data sync, loading data. Okay, cool. Okay, that looks good. Oh, it got fancy on us. It's going to use a class. Ooh. All right. Okay. All right, let's put it in here. All right, guys. And then I forgot what the pip install is. Maybe somebody in the chat knows, but let me quickly ask our employee here. PyTorch is okay. It's just Torch and Torch Vision. Not using this example. Okay, so I just need Torch then. Actually, I think I'll need scikit-learn too because it's a new environment. Okay, so I might need all of this. So let's quickly do those installs just to kind of get that out of the way and get our environment ready. So again, this is just a standard, Conda creation of my environment. It's the exact same way I created it for the Keras side. So let me just get this out of the way and we'll let that install. I don't anticipate any problems with that. So let me go back to the code. All right, guys. So just a couple different things that are jumping out at me. This is basically the same, right? This is basically identical to what we saw on the Keras side, right? It's prepping our data, it's separating out the labels, separating out our train test split. Again, it's using 0.2 for the test size. It's scaling our data. And then here is where the PyTorch specific code begins, right? It's going to go ahead and set up our tensors. It's taking that everything is a float 32. So if you guys have attended before, you guys know that we've had some problems in the past, right? With, the data or the data format handling. So we'll see if that goes okay. It's treating our target variables as a long, which I guess is okay I guess it's okay. And then here we go, right? First of all, just in case you don't recognize it, it is going to go ahead and put it all in a class. It's taking the neural network and making its own class for it. So here is the initialization routine, and it's basically designing the neural network, right? So here's our input of 20 again with the 64 neurons. Again, from 64, we're going to 32, 32 to 16, 16 to 5. So to me, that validates that these are identical neural networks, with these two being our hidden layers, right? Lines 37 and 38 being our hidden layers, and it's also in the comments, right? And then we know that 5 is our final output because that's how many classes there are in our supervised data set. It's going to go ahead and use a forward-only approach to the training. We're out of the class now. We're instantiating the class. We're claiming the cross entropy loss, which is the same loss we had on the Keras side. It's using the Atom optimizer, which I believe was also used. It was, right? So that's the same optimizer. And we have the same number of epochs, the same batch size. And then here, it's going to give us a little bit more control over the epochs in the sense that each epoch runs on its own, right? But again, this maybe kind of is a better way to illustrate what I was referring to earlier, where you'll notice that after each epoch, it goes ahead and uses the same model over and over again. So that's where it's maintaining the same, it's using the same network, but the network is maintaining the previous knowledge, right? And that's very valuable. That's something kind of makes neural networks unique in that way, right? So it's going to go here, run the epochs. We declared 10 epochs, and that's it, right? After that, we're just doing an evaluation of the model, just like we did for the Keras side, and we're doing a confusion matrix. That's it. Right? So pretty straightforward. You know, I like the code. The code is, you know, it's unique that it's in a class, but I like that ChatGPT, our employee, was able to duplicate the Keras efforts pretty well, right? I mean, this speaks to the power of ChatGPT as far as how well it works. Anybody have any questions, or are we just ready to run this? Give me some feedback in the chat. Give me a 1 in the chat if you're just ready to run. Let's just go. Because remember, at the end of the day, we want to know the accuracy numbers and the validation numbers, because like that's the benchmark, right? Maybe Keras will be better. Maybe PyTorch will be better. Who knows? Yeah, Rex, thank you so much for playing host on Instagram. Also, thank you for that. Okay, yeah, I'm seeing some 1s in the chat. I think people are ready to go here, right? Yeah, let's do it. So let me make sure I'm in the right terminal. Yep, all the installs went well. Leo says, let's go. Time to prove how PyTorch is better than Keras. Leo, I have a stop stream button right below my chat. Don't make me press that button, Leo. I will stop this stream right now. For those of you guys that don't know, I am a fan of Keras. Okay, full disclosure, I've contributed open source to Keras. I have a pull request that's accepted in Keras. One of the highlights of my career. I'm also the moderator on their mailing list. You know, just so you guys know, you know, I moderate the email list for Keras. So I am biased towards Keras. So Leo's testing me. He's testing my will. I will stop this stream, Leo. All right, guys. Yeah, so neuralnetwork.py. Let's run it. Neural. Let's see what happens here, guys. So 89, right, was our validation on the Keras side. 0.89. Oh, geez, I didn't do Panda. Sorry, guys. Oh, import pandas. I'm an idiot. Oh, that's hilarious. I'm getting old, guys. Oh, look at that, guys. All right. What do you guys think? Interesting. A couple things are jumping out at me. What do you guys think? Rahul says, based on this output, we think that PyTorch is indeed better than Keras. Okay. Okay. What other observations are out there? Yassine says, well. Michael is still thinking about it. Monium says, not much difference, actually. Okay. So guys, I think we can adjust the code to show the accuracy. This is just showing loss, which is a valid metric. But just so you guys know, when it comes to loss, lower is better. You want high accuracy and low loss. Okay. You know, I know a lot of you already know that, but you know, we also have some new people. But lower is better for loss. We can probably, you know, see if it'll give us the accuracy output per epoch. But loss, lower is better, okay? We deal with randomness here, and I believe running the TensorFlow and PyTorch examples, we will have comparable results. So Maniam, help me understand this, but I think you're saying that you're not seeing enough variance there to say that there is a big enough difference, right? Because you know, to some degree, you're right. We're talking about 0.89 versus 0.90, right? So yeah, maybe that's, you can just say, hey, look, you know, that's just noise, right? Like, you know, it's not significant. You can just say, well, you know, it's noise, right? 0.01 difference, right? So if that's what you're trying to get across, I'm on board with that. But help me understand if I got that right. Anybody else? Anybody else? Let me bring this over for the some of the Instagram people. Anybody else? Nobody else? Last call? And Keras loss was much less than PyTorch. Okay, I like the observation. Yeah, and you're right, Lakshmi. I mean, look at Epoch 10. That's not a great loss, right? 0.58. That's terrible. Maniam says, yes, I'm trying to say that. Yeah, and I see where you're going with that, Maniam, right? It's just variance, right? The next time you run it with a different train test split or whatever, right? A different set of train test split, whole other result, right? So yeah, you're right. So, you know, I don't single people out, right? But Yassine, my good friend, I'm surprised to not hear from you. What about this confusion matrix, Yassine? So guys, take a look at this confusion matrix. Isn't that just completely different? I think the same classes who had good accuracy and care. Is that true? What about class 3? What about class 4? Maniam says loss is changing from one epoch to another, not decrease. Yeah, Maniam. Yeah. That's not good, right? Seeing an increasing loss like that, I'm not encouraged by that. But again, what about 20 epochs? That's what we're going to do next, right? We're going to do 20 epochs on both sides. What happens then? Super interesting, right? But yeah, Maniam, you're right. But the loss here is not 100% encouraging. But coming back to the confusion matrix, Yassine, what do you think about here? How do you explain class 3? How do you explain class 4? I don't know. You could argue that PyTorch did better here, right? Leo says, Dennis, what would be your elevator pitch for using Keras? Just curious. Sir, Mr. Managing Director, I need $20,000 to send my staff to Keras training because none of us grew up in broken homes. All of us grew up with fathers in the home, so we don't want to learn PyTorch. Thank you. I mean, the ones that are poor stayed like that, and the others just got better. In the Yassine, I don't think that's true. Class 3 was not this good in the previous one. Class 3 was terrible. So I don't agree with that, Yassine. Class 3 did really good. I think even Class 4 did, you know, like not a ton better, but it did better than Keras. Leo says, ha ha, Manosha's low. That was brutal. What? What did I say? What? You asked me for my elevator pitch. It's not my fault that my father didn't go out for cigarettes one day and never came back. Guys, come on, I'm being honest. You guys know that I'm always honest with you guys. And I'm just being honest. I use Keras because I grew up with a father in my home, okay? I'm sorry. Oh man. I'm telling you guys, I could have 100,000 followers tonight if I put out a video talking about PyTorch sucks. Because you guys always, I get so many comments raising their fists. Why do you hate PyTorch? Oh man. All right, but Yassine, that's jumping out at me. I think classification wise, it kind of did better on some of these classes. All right, so I think a very reasonable next test is let's do another head to head, but 20 epochs, right? Because we know Keras was going like this, and PyTorch a little more variance, right? So 20 epochs, guys. Let's do it. So give me some predictions. Give me some predictions in the chat. What's going to happen? We're going to double the number of epochs. And I explained to you guys what an epoch is, right? It's learning, building on top of learning, building on top of learning, building on top of learning, right? So more epochs, more better in theory, right? There's a diminishing return, but what do you guys think? Give me some predictions. All right, so we're gonna go to here. We can fix it quickly. It's gonna be here. Number of epochs is 20. Control C. In Keras, that's gonna be in the fit. 20. Okay. Here it is to Keras. Alpha says, I have a doubt. Let me know what you mean by that. Michael says Keras will still do better. Okay. All right. So we're getting some votes for Keras. So let's do the Keras side first, okay? Just to kind of keep the order. I put my faith in Keras by Anise, okay? Okay, so here we go with Keras, guys. Hmm. 0.914. And here's our confusion matrix. Let me bring that over for the Instagram side. And look at our validation accuracy. So a little bit more variable this time, right? It seems to kind of cap out at 0.91, a little more variance, but still kind of sorta on an upward trend. So, another 10 epochs wouldn't hurt here. But look at our accuracy now, 0.915. Monium, you can't say that. You can't. What's your rationale for saying 2 points higher? Like, I agree with you, there should be higher, but to put a quantitative value on that, I'm not sure how that's possible. I'm not on board with that, Monium. I'm on board with the concept, but not the quantitative value. You can't say that. It's dependent on your data, your use case, your network design. You can't say that. I'm not on board with that. What do you guys think? 0.91, confusion matrix up on this screen. Class 1 did really good, right? Class 3 did really good. What do you guys think? Could you elaborate more on classes for the? Sure, Leo. Which classes? Are you talking about Python classes or the classes like that we're talking about here, like the like the categorical classes? Help me understand which one, Leo. Okay, so well, yeah, let's go ahead and run the PyTorch side, right? But so right now we're at 0.91 with Keras. Okay, Leo, for the categorical ones. Let me come back to it, Leo. Let me kick off the Keras, the PyTorch code. All right, so PyTorch guys, we already made the code changes, so let's go. Okay. So here we see a very small improvement in the accuracy, guys. And here's our confusion matrix. Okay, so Leo asks about classes. And that's a great question. So when you think about classes, it's basically different. It's all going to depend on your use case, but it depends on a class is basically a prediction. It's a label that you're willing to add to your results based on your inputs. So you can have tons of classes, like binary classes. So that's like a yes, no. So that could be like spam or not spam. I take the input of a message, I read it, I make my calculations, and I label it as either spam or not spam. Right? Those are two categories. The message is spam or not spam. But what if I want to take that message and then I want to say, and you're working for a customer service department, and your company has 5 different product lines, right? You offer industrial equipment, office equipment, safety equipment, whatever else, 2 other classes of sales. You're taking in the same messages and now you're saying, oh, that message is about cleaning equipment. That message is about office supplies. That message is about whatever. Each one of those is different classes. Right? Because you're categorizing, right? That's what it's called, a categorical problem. You're categorizing what your input data is about. So this is important because this is basically telling you that the confusion matrix you're seeing, this is telling you how well each one of those classes would apply or would work. Because you don't want to see spam messages if it's a spam message, right? When your Gmail shows you a spam message, that's a mistake by the algorithm. It miscategorized it. So that's what this confusion matrix is a representation of. How many times was it classified correctly versus how many times was it classified incorrectly? So that's why we're looking at this, because it's a good measure, not just how the algorithm is performing, but ultimately how good your users will accept your product. You're not very happy when you get a spam message, right? Does that make you think that Google's doing a great job with their algorithms? No, right? So it's a reflection of the quality of your work. Now, it's never going to be perfect. Algorithms make mistakes, right? And those mistakes have different impacts based on your use case. But that's why you want to look at the confusion matrix, because it gives you an idea of essentially of how well your product will be received. Okay, so Leo, thanks for the question. I should have taken more time to do that, but I hope that's clear to everyone. If not, put the comment in the chat. But yeah, great question, Leo. Thank you. So Manium says it's just a hypothesis watching the trend of validation, accuracy, and loss values. Okay, Manium, if you meant for this particular problem, like that's the trend that your eye saw, okay, I'm on board with that. But just be careful about saying that across the board, because I thought you were making that as a statement across the board. Manium says, I believe actually given the results for Keras, I believe epoch 15 is the optimum number of epochs. Maybe. You don't know that. You don't know that because what about network design? We haven't touched the network itself. Right? We could be tooling with that. Remember, guys, that's the beauty of hyperparameters, right? That you can fool with so many different things. Right? So, yeah, maybe. I mean, right now we're kind of, and maybe I should have been a little bit clearer about that. I'm willing to fool around with the epochs because we're doing more benchmarking, like head to head, right? But generally speaking, epochs is not considered a hyperparameter. It's considered more of a tuning to help you understand where the model is going, right? And that's why I say, well, hey, we were on an upward trend, we were on a downward trend, because it gives you an idea of whether you're on a viable path or not. So again, this is outside the scope of what I want to cover today, but in neural network training and all of that, there's this concept known as early stopping, where some of these companies are training so many models over so much time that it's valuable to sit here and monitor your epoch progress. Because if you have a baseline and you're at 0.93 for your validation accuracy, let's say, right? And you're 20 epochs in on a new model that you're trying, and that epoch is at 0.65, then that's an early stopping scenario, because that's not going to beat my 0.93, right? So we're doing the epochs to kind of help deepen our understanding, do the head-to-head matchup. But the epochs, like, you really shouldn't say, oh yeah, I think we should tune for 15 epochs. It's the other way around. You should be tuning your model. Okay, guys? So I really hope that you guys have an understanding of that, that don't think of epochs as hyperparameters. It's more of just like, how are you progressing? Right? Like, are you getting, again, going back to that example of the semesters in college, are you getting dumber or are you getting smarter? You should know because you've taken the class 10 times now. Like, are you literally doing better or are you not? Right? So just keep that in mind, guys. And a lot of these concepts, maybe I'll do like a more advanced neural networks class, but the rabbit hole goes a lot deeper than what we're doing today. Today I'm kind of keeping it surface because I recognize that there's some new people in the chat, right? It goes a lot deeper than this. Okay. Okay, guys. So start giving me some comments in the chat. What do you guys want to do next? You want to add more layers? You want to do more epochs? Give me some ideas. Do you want to change the train test split? We could do that. There's trade-offs to doing that, but people do it. Not always a good idea, but people do it. What do you guys think? Give me some comments in the chat. Where are we going next? I got some ideas, but I want to hear from you. All right. Rahul says, is the loss for PyTorch better than Keras in this instance? And how do we measure the trade-off between loss and accuracy? Yeah, Rahul, great question. So I would say that the loss is still kind of variable, right? Super variable in PyTorch. I mean, look at this. We're as high as 0.51. We're as low as 0.06, which is a great loss number, by the way. 0.09, but then we end off with 0.23, 0.10. Super variable. So I don't know. Rahul. I think it's variable. Too variable to call, Sir, if I may say, could the difference be because the two libraries use different learning rates? I didn't see a difference in the learning rates. So no, I don't think that's the case, Yassine. Now, however, Yassine, learning rates do make for an excellent hyperparameter, right? Learning rates are a very, very good hyperparameter. But no, I haven't seen that learning rates are different between the two, the two matchups here. So Leo says, I think adding layers. Okay, Leo. Anybody else? So Leo votes for more layers, which I think is it's a valid thought. What do you guys think? Monium says, reason I put forward this common 15 epochs is related to the comparison of the training accuracy and loss and validation accuracy loss and the trend of validation at epoch 15. Yeah, Monium, but that's only this one instance though, right? And also, I mean, if anything, going to 20 here, we've seen that PyTorch is super variable, right? Super variable. I mean, at 15, we got 0.9, but we also ended with 0.23. That's like double, right? That's like 2.5, right? 2.5x, right? So that's just too much variability, right? Yassine says, I think it might also impact it. Yeah, you're right, Yassine, but there's no difference in the learning rate right now, right? We're holding that static for now. We wouldn't do that in serious development. But for the purposes of a head-to-head matchup, we're holding that static. Okay, Michael says, I agree with Leo. Okay, yeah. So let's do it. Let's add another layer. Super easy to do in both models. So right now we're in Keras. All right, guys, so start giving me numbers. Do you want to go bigger? Should we add it to the beginning? Go, pick something for 32. Like we could go like 128 here and then like 64 as our first hidden layers. Or should we go smaller? Should we add an 8-node layer? There's trade-offs, right? More calculations happening, right? What do you guys think? I'm gonna propose this, guys. You tell me what you guys think. All right, if you guys want to change this, let me know. But I'm gonna propose that we go big. Or bigger, I should say. Let's go 128. And then let's go 64 here. What do you guys think? Give me a 1 or a 0. 1 if you're on board, 0 if you want to do something else. All right, Leo's on board with this. Anybody else? All right, Anise is on board. Lakshmi's on board. Okay. All right, guys. So we're going to do that. Now, what have we done? Have we increased or have we decreased our processing requirements? Let me know in the chat. Increase or decrease? What have we done here? Have we increased or decreased our processing requirements, time, all that stuff? What do you guys think? So let me go make the same change in PyTorch. What do you guys think about that? Okay, we're gonna do this. And it's gonna be what? It's gonna be 128 here. 128 here and 64 here. Yeah. What do you think, guys? Have we increased or decreased our processing time, our requirements, all that good stuff? Yeah, that's right, guys. We've increased it, right? More layers, more nodes, more calculations. But yeah, that's exactly right. Yeah. Okay. I think we're ready to go. All right, so where are we? I think 0.91 for is our baseline model, our leading baseline model for Keras, right? Yeah, so Keras has us at 0.915 for our validation accuracy. Okay, so everybody keep that in mind. 0.915 is our benchmark that we're trying to, or our baseline model, as we would say. Okay, and we're keeping it at 20 epochs. Does that make sense to do that? Yeah, I think it does. I think it does. All right, guys. I think I made those code changes correctly. We're about to find out. Yep, it looks like we're fine. Wow, look at those numbers. Here's our confusion matrix. Leo says, what about trying softmax over ReLU? Leo, we could try other activation functions, additional activation functions, but I don't want to get too far off the reservation here, right? Because I think that's more optimizing a model after you've chosen a framework. I still want to stay focused on the individual, the head-to-head matchup. So I for the purposes of this, I'd rather hold it static. But in the future, you might want, you might have those use cases where you're going to try additional activation functions, okay? What do you guys think? Rahul says, it seems in this instance, Keras has performed worse to 3 layers, loss has gone up, and accuracy has gone down. Yeah. Yeah. Now, here's the thing, Rahul. This is kind of, I mean, I might be wrong, and I'm open to being wrong. Yeah, yeah, maybe I'm wrong here, but I'm looking at the validation accuracies. I'm looking at all these numbers, right? This column of numbers here, basically. Your observation is correct, but doesn't it feel like the mean of these numbers has gone up? Like, that's what's catching my eye. I feel like the mean of these validation accuracies is higher than what we've seen before. Because we don't always want to focus on the last epoch. We want to focus on the training as a whole, right? So to my eye, it feels like the mean of all these numbers is a little higher, which to me indicates like value, right? More epochs or, a different sized model. But there's something here, right? What do you guys think? That's just my observation, right? These are the conversations you have in the team room, right? Like, hey, this is how I see it. How do you guys see it? But to me, the mean seems to have gone up. Leo says, and also the loss, I don't think it's higher than before. Yeah, Leo, I mean, it doesn't look too terrible, right? I mean, the end result, the 0.32 at the end was not great. But overall, it's not terrible. So I agree, Leo. Rahul says, yes, I agree. The mean is higher, the variance is low. Yeah, Rahul, and that's a good thing, right? Like, to me, that's like, like one of those signs of life, right? Like, you want to have those things. So yes, maybe the accuracy isn't what we had before, but there's potential here, right? Monium says, it seems with this instance, based on the validation accuracy, it went up. No, validation accuracy went down, my friend. We could employ early stopping and avoid overfitting here. But it actually went down. If anything, we'd have to run more epochs to determine that, right? But no, our validation accuracy went down. We got 0.915 was our baseline. All right, let's go to PyTorch. Actually, let me shut. I gotta shut this. Okay, so let's try PyTorch. I already made the code changes. Yeah. Oh, did I make a mistake there? Did I make a mistake there, guys? Does anybody spot that mistake? Just verify that. Yeah, 20 to 128, 128 to 64, 64, 32, 16. Yeah, Leo, so the error is saying, let me bring that back up. For mat 1 and mat 2, shapes cannot be multiplied 32 by 128 and 64 by 132. And it's on the model side. Ah, thank you, Monium. Yes, you're right. Thank you, thank you, thank you. Yep. Oh, yes, yes, yes. Sorry about that, guys. 5, you're right. Yeah, I try to make those changes too quickly. Thank you so much. Guess this needs to be. All right, so Karis wins, and how quickly we can make those changes. Yeah. Yeah, thank you, Monium. A great catch. I was just too quick in making them. 1, 2, 3, 4, 5. 5 is our activation layer, output layer. Yeah. Change the naming FC in the forward. Yeah. I think I got them all. Thank you so much for that. Yeah. Okay. All right. What do you guys think? Monium says, and that is why Karis rocks. Nice, Monium. Monium understood the assignment. Thank you, my friend. What do you guys think? Leo says not much of a difference. Okay. Compared to Karis. Okay. Anybody else? I think Leo's making good observations, right? Rahul says huge variability in the loss, accuracy is slightly better. Yeah, Rahul. Both of those items caught my eye. Again, if we just get like a sense for the mean here, seems super high, right? Some of these values that we're seeing in this loss were outliers in our previous tests, right? In some of those other tests, we were getting 0.0 something, right? We saw an 09 and 06. We're not seeing any of that. We're seeing a 5.7, a 4.3, a 3.7, a 7.3. These are terrible losses, right? So it does feel like it's variable and the mean is higher. But having said that, another thing that's jumping out at me is, guess what? On the PyTorch side, if we just think about PyTorch, this is our highest accuracy number yet, right? This is the first time we've seen a 91 from PyTorch. So, is that good? Is that bad? I don't know. Depends on the use case. Depends on what you think about PyTorch as far as like where you can take the code. Leo says, yeah, Leo. I mean, I think it's clear, right? Like if you look at these numbers, like the mean of the loss is probably the highest we've seen. Like 0.73 for a loss? That's terrible. Even 0.33 is, not so hot. Right? The confusion matrix looks okay, right? Class 1 and class 3 are excellent. Yassine says, if I remember correctly, the code that generated the data used 15 informative features, just a dumb thought, but wouldn't it make sense to use a layer with 15 neurons before the output layer? My rationale is if we already know how many variables are significant, let's consider every neuron as a variable and let the model learn them. So Yassine, it's not the output layer, it's the input layer that matters at that point. Right? See, I'm not on board with where you said about the output layer because your features and your outputs are, there's no relationship there. Your inputs are what they are and your outputs are what they are. They're completely independent of each other. Right? I mean, that's why you have the layers in between, because the layers and those calculations is what helps you make those relationships, right? Those relationships that you can't see. But there is no correlation between your inputs and the number of outputs. In many cases, it's much more common for the outputs, but in many cases, they'll be dictated to you, right? Like the number of categories your business needs is what the business needs. You don't decide that. And the features don't decide that. So no, Yassine, I'm not on board with that because they're completely independent of each other. On the input side, it matters, right? 20 features needs 20 nodes to start off. But otherwise, no. Doesn't matter. They're completely independent. But I'm still confused in real world scenarios. How would I select a model? What balance of losses and accuracy is what I'm looking for? Yeah, Rahul, depends. It all depends. It depends on the use case. And again, some of those, they might be dictated to you, right? So for example, going back to this chart here with the classes, let's talk about this chart. Can I make this a little bigger? I can, cool. Let's talk about this chart. So I know it says the class 0, 1, 2, 3, 4, but these in most scenarios, these would be like product classes or some sort of end result to a process, to a sales process, to a production process, whatever, right? So the business might dictate to you what they need out of this, right? So let's take class 3, right? Class 3 is properly classifying 393 of the 400 items that are in that data set, okay? And you know that the accuracy here is 91, the loss is a little shaky, right? We've already agreed on that, right? But the business might come to you and say, that's fantastic, we want this model. And they're going to tell you that they want the model because these, any number that's not in the 393 is basically a mistake, right? And the business might tell you, well, every time you properly tell us this, we make $500. And every time we make a mistake, we lose $3,000, right? So we're ecstatic that you're only making 4 mistakes. Like, that's great. And then you're going to say, but wait a minute, this model really stinks for class 2. And they're going to say, that's okay, because these mistakes only cost us $10. Right? So we're okay with a model that's optimized for class 3, because that's when you're saving us the most money and you're making us the most money. Right? So it's totally okay, for you to make those adjustments. It will be like literally dictated to you to say, I don't care what the model looks like. I don't care what you use, Keras, PyTorch, a room full of monkeys. Just don't make mistakes in class 3 because those are really expensive mistakes. Like, I've been in situations where that happens, right? Like, you can sit there and you can break it out and actually assign values to your mistakes. And then sometimes the outcomes themselves have probabilities. So you got to do, these expected value formulas, blah, blah, blah. But you can sit there with the business and they will tell you that I don't care about the accuracy. I just care that you're not making a mistake here, because that's where our money is, right? So Rahul, you're asking a great question, but it's not always an academic exercise. It's not always a black or white answer. Like, it will be dictated to you, and there will be some hard numbers behind it. Like, some very logical numbers behind it, right? So yeah. So that's really my best answer to you. So Leo says, yes, but achieving a higher accuracy without overfitting is a heck of a challenge. Yeah, but it might not matter in that scenario, right? It may or may not matter in that scenario that I'm telling you about. Again, they can assign dollar values to all of these. So they might be okay with an overfit model that optimizes for class 3. Because again, those mistakes are very expensive. And they could tell you, hey, right now we're making 50 mistakes a day that cost us $3,000. If you're telling me you can only make 4 mistakes that cost us $3,000, we love you, right? They're going to love you for that. And again, they don't even care if it's Keras, PyTorch, or a room full of monkeys. They just don't want mistakes in class 3. And they're okay with mistakes in class 2 because those are the cheap mistakes. So it just depends. It just depends, guys. That's the real world stuff that, even the academics don't have a good grip on, right? Because in academia, they want perfection, right? Don't overfit that model. Give me a model that meets X accuracy. Well, that's not always the real world. That's the academia world, but that's not the real world, right? And again, I'm telling you this because I've been in those meetings where we will sit there and we will say, okay, well, here's the cheap mistakes, here's the expensive mistakes, and that's where we want you, Dennis, you, the data science team, to go in that direction. And then Leo, as far as like how do you actually achieve that? You know what? Sometimes just Monte Carlo it, right? You can Monte Carlo this. You know, you'll have to set up a process. You'll have to monitor your outputs. You monitor your accuracies, monitor your confusion matrix specifically for the class that you're interested in, and just let the processor fly, right? And then eventually you'll come across a model that meets those needs of saying, yeah, this is your best outcome for the business, not for academia, not for perfection, not because it's the best accuracy or F1 score or whatever, but because it's what the business needs. Rahul, so the follow-up from Rahul, so you are saying that whether Keras result is better or PyTorch depends on the business problem, and always the last epoch is the final version of how the model will perform for the new data. Okay, you're asking two separate questions there, but let me take on the business problem side because I want to stay on this topic. So the purpose of today is more to show you like the differences in how the models come together. We've already seen some of the differences in the code, things along those lines, right? That's really kind of the purpose of today. So I'm really not trying to say, oh, for this business problem, Keras is better. For that business problem, PyTorch is better. When I'm talking to you about, you know, the losses and the confusion matrix and the mistakes, I'm saying that agnostic of any neural network design or tool that you might use, right? I'm using that to give you the real world view, right? Because this is how neural networks, or, you know, really any model is used in the real world, right? And the real world is not about perfection. It's about the business impact. And that's how you will measure business impact sometime. You can make, you know, the business will tell you can make a mistake here, but don't you dare make a mistake here. So that model isn't going to have perfect accuracy numbers, right? But that's okay because that's what the business requires. That's the request that has been made to you by the stakeholders that you serve, right? I mean, ultimately, that's what we do. We serve our stakeholders, right? So Rahul, I'm trying to present all of this independent of tool, right? Rex says, so the value behind recall precision and accuracy are contextual. Absolutely, Rex. Yeah, absolutely. Yeah, and we've talked a little bit about this before, you know, as far as like the precision and the recall, right? I think I know some of you have heard this, but there's a lot of people that are new. The example I've given before is like a credit card transaction, you know, detecting fraud, right? So there's two mistakes you can make there. You can let a fraudulent transaction go through, or you can block a legitimate transaction by a legitimate customer, right? Completely different costs behind those, right? If I'm a legitimate customer and I get my transaction declined, what does that cost the credit card company? It costs them an annoyed customer, right? I'm annoyed, but I'm probably not going to cancel my credit card over that, right? If I'm a fraudster, and they let my transaction go through, credit card companies can assign what the average value of a fraudulent transaction is, and they can say every time that mistake happens, we lose X number of dollars, right? So huge imbalance there in the costs, right? So yeah, I mean, and I'm saying that to Rex's question, that's a precision recall problem, right? But it's clear which one you want to optimize for, right? Like that's 100% clear which one you want to optimize for. An annoyed customer, on an average basis is not going to cost you a lot of money. Like, yes, some non-zero percentage will cancel their card, but like 1 in 1,000, right? So the cost on that is very little to a credit card company, but they know how much an average fraudulent transaction costs them, right? In real dollars. So yeah, Leo, excuse me, Rex, it's all contextual, right? And like I say, a lot of the times this will be dictated to you. And that's okay. Real world data science is not about perfection. It's about serving your stakeholder. Perfection in models. I mean, obviously you want to do a good job, guys, right? But it's not about perfection in models. It's about serving your customer in the best way possible. So Rahul says, so how can you optimize your model for a particular class? Sorry, this is out of scope. We're going slightly out of scope, but I don't mind having this discussion because it's an important one, you know, and because really, again, realize guys, we're talking about data science in general. We're not even talking about neural networks, and certainly not PyTorch or Keras specific. You know, this is just, you know, data science overall. Stakeholder management. But Rahul, there's not always a way to do it. The way to do it is that you're going to have a process where you're going to try a bunch of different models. You know, basically you're kind of Monte Carloing it. You're going to set up, you know, your monitoring systems in the background to look at the metrics of each model as they finish training. And then you're going to say, oh, that model has a great accuracy for class 3. So let me go ahead and save that model. And then that you would call like your champion model candidate and say, oh, okay, cool. Now, you're getting there because you're trying different hyperparameters, maybe different model designs, different activation functions and things like that, right? But that kind of doesn't matter, right? That's kind of like why you're Monte Carloing, because you don't know what the answer should be, right? But whatever that model ends up being, if you can go back to your stakeholder and say, hey, look, you know, we developed this model. This is what the confusion matrix looks like. This is how many mistakes that one class is going to do. These are the mistakes in the other classes. What do you think? How do you feel about this? And they're going to tell you, right? Leo says Monte Carlo is a probabilistic model for those a bit lost. Yeah, sure. Yeah. You know, I know that's the popular way to think about it, but honestly, Leo, I just think of it as brute forcing it, right? How do you get the right answer? You try every answer, right? I mean, that's kind of like the dirty secret of Monte Carlo, right? Like, I think they gave it like this fancy sounding name to make you feel better, but you're just brute forcing it, right? I mean, that's all it is. You're setting up all your parameters, you're setting all your loops to try those parameters, and you're just letting it fly for the weekend, right? You let it go on a Friday afternoon, you let it fly, you come back on Monday and see what happens, right? So yeah, you know, technically speaking, it's a probabilistic model developed, you know, back, I think in the 70s or something, but you're just brute forcing it. Shut up. Put your academic books away. You're just brute forcing it. Rahul says maybe in some future Sunday session we can discuss Monte Carlo and other similar situations. Just a suggestion. Yeah, Rahul, that's a great suggestion. So that's been requested before, and the way it was requested before was more about saving the models and how do you identify those champion models. Because I think Rahul, you might have asked the question previously about, well, is that last model our best model? And the answer is no. The last model just tells you how you were progressing, but that's not always your last model. Sometimes it is, sometimes it's not. But you should be saving models along the way. And there's ways to do that, right? You keep a benchmark number. How did my accuracy do against my benchmark number? Is that a model I want to pull out and highlight? Like, I haven't shown that, right? Because again, it's kind of out of the scope of today. So if I were to do that, Rahul, I would do it in that way to say, okay, well, look, let's really talk about the greater scope here. And the greater scope is, how do you manage these experiments? Because another part of the Monte Carlo is, well, how are you determining those loops? Well, you're determining those loops by your hyperparameters, right? Okay, well, which hyperparameter should I be changing? You know, and so on, right? Because that's really what you're asking, right? So yeah, not a bad idea for a Sunday session. Like I said, it's kind of been sort of requested before. But that's a much deeper conversation. So that's something I'd probably have to prepare a lot more for. I could probably wing that one because I do have my own methods that I follow. But yeah, it's such a much more complex conversation to have. But I hear you. You know, it's in the back of my mind. It's on my list. It's on my list of 728 ideas that I want to do for you guys. So it's on my list somewhere. But yeah, I've heard that before. So thank you, Rahul. It's on the list. It's on the list. All right, guys. So yeah, you know, like I said, guys, we see some interesting results here, but this is the best PyTorch result we've had today, right? Like 91 is the highest number we've seen for PyTorch today. Another thing that I think is also interesting, if you guys think about it, these models have all run in a reasonable amount of time. We haven't really had a model or a design that has really stressed the CPU yet, right? Like we're not doing so bad in terms of like stressing the computer, right? So we're actually not doing so bad in terms of like the resources. I'm kind of pleased by that. Rahul says, thank you so much for explanation again. Maybe I will have a thorough read about this to understand. I'm so curious now, huh? Yeah, and thanks to Leo for posting the book earlier. It's called Build Your Own Neural Network by Tariq Rashid. I want to give him all credit because, again, reading that book and doing the exercises I just told you about really helped move me forward when it comes to machine learning. So, you know, I want to give appropriate credit there. But yeah, you know, like, obviously I've worked with neural networks, you know, in my career, but if you guys want to learn more, you know, I would definitely start there with the Tariq Rashid book. Leo says M1 still breathing fine. It is, right? Like, it's not like we haven't stressed the hardware at all, guys, right? Like, it's still doing well. So let's do that. Let's try to push the envelope just a little bit. Let's go to Keras, because we know we can add layers really, really quickly to Keras, right? Let's add a few more layers, guys. Let's see if we can maybe, you know, kind of start to find where things start to slow down, right? So what if we did this? What if we did an 8? And then what if in between here we did what's a good number in between here? Somebody give me a number. Start giving me some numbers, guys. Let's duplicate some of these or add additional layers or different numbers. What makes sense here? Like a 12? And then over here, what? Like a 48? As a step down, right? 64, 48, 30. Yeah, I think that makes sense. What do you guys think? And what if we went to 256 here? And then what if we went to 128? Let's try to tax this machine just a little bit. $64, 128, what is that, 96? Is that the middle point? Right? 64. Oh yeah, 96, I believe. All right, anybody else? 256, 512. Yeah, okay. Let's do that. Let's go to 512. 512 and then go to 256. All right, guys. All right. Hey, so if the stream ends all of a sudden, that means my computer crashed, okay? All right. Let's go back to my Keras terminal. All right, remember guys, this is not really a Keras test. This is more just like an Apple M1 test. Oops. Wow, that's not bad. Each epoch is still taking just a handful of seconds. That is not bad at all, guys. 929. Woohoo! That's our highest number yet, right? 929. That's not bad, guys. $929 is our highest value yet on any of the models. Loss isn't as great as we've seen, but 929, and again, it's on an upward trajectory, right? I mean, look at these numbers. It's kind of an upward trajectory. Yeah, so interesting. Interesting, guys. All right, wow, we've gone for 3 hours, guys. That's incredible. Okay, guys. So, as I always tell you guys, and I encourage you to follow this, every good study ends with go forward steps, right? So, what are some good go forward steps here? One, other types of data, right? This is all numerical data. What about NLP? What about image processing? Right? That would be interesting. What about different hardware? You know, technically I'm on a Mac. Maybe it'll respond differently on Windows. Maybe. What else do you guys think? Give me some comments in the chat. What are some other potential future steps? What else? Different network design, right? Additional network design. Different layers, different types of nodes. We haven't even gotten to the different types of nodes, right? That's kind of like a whole other animal to talk about. But what do you guys think? Let me know. All right, so Leo is interested in image classification. Yep. So just so you guys know, in Tariq Rashid's book, like the final like capstone project is an image classification project. So another reason to go pick up that book. Rahul says comparing output with traditional machine learning models. Do you think? Yeah, sure. Yeah, you know, Rahul. You know why I like that suggestion? Because so many people are stuck on, oh, well, neural networks are so wonderful. They're great. You know, they're this, they're that. But they don't take their problems and then try to solve it with regression. And guess what? Regression does just as fine, right? Oh, regression, that's an old method. Nobody uses regression anymore. Who cares? There is no old and new when it comes to models. There is no newer, better, younger, older. That doesn't exist. So yeah, that's a good one, right? Take this and put it in that old school regression model, and regression might do better. You never know. That's why you do model searches. Yeah. So Rahul, I love that suggestion, right? Neural networks versus regression, right? Maybe we should do that. All right, guys, next Sunday. Yeah, I'm just kidding. I don't know if I'm going to do that. But yeah, who says neural networks are so great? Right? Maybe we should do like a regression matchup. So yeah, Rahul, love the suggestion. I'm going to add it to the list, Rahul. You're on the list twice. Dennis, will you please confirm the book? Yep. Make Your Own Neural Network by Tariq Rashid. I'll put it in the Discord later today, you know, but you want to check that out. Make Your Own Neural Network by Tariq Rashid really moved me forward in my learning and in my understanding of neural networks. So I hope this session has also moved you guys forward. It's been really great to spend this time with you guys. I hope you learned something. I think we learned that, it's interesting code. They each have their pluses and minuses, maybe some more study to come, but I hope that each one of you got a sense for definitely for neural networks overall, but got a sense for both Keras and PyTorch as far as the code goes. As somebody mentioned in the chat, maybe there isn't enough of a significant difference there to say, oh, this is clearly better, right? I could see why somebody would say that, right? We haven't really seen like a massive, distinguishable difference. Yeah, so Leo, I'm not sure if there is a verdict. I'm willing to say that, it's to be determined. To be determined. Again, I like Keras. I'm biased towards Keras. But we really can't say that, there was such a big difference. Keras is clearly better. That wouldn't be fair of me to say, right? Can't say it about PyTorch either, right? So really, it's almost like, well, what code do you feel comfortable with? What does your team use? Again, you have to adjust to the team. The team's not going to adjust to you. So, kind of to be determined. Kind of to be determined, guys. Right? If you feel differently, let me know, or let me know in the Discord. But I think it's been time well spent. We've gone 3 hours. That's one of my longest streams yet. But yeah, just really appreciate the time that we spent together. Appreciate all the support from you. A lot of new people today. So thank you so much for attending. Please join the Discord if you have other questions, want to keep the conversation going. I know some of you just come on Sundays, and that's cool, but I also stream every day, 1500 GMT. But I appreciate your support, guys.